yesterday and put in the back of the room. The whole point of a confidence interval is to be able to take an estimate, so like a sample mean or a sample proportion, and then try to infer or estimate what we think the unknown parameter might be. And the unknown parameter would be like the true population proportion or the true population mean. So we need a good sample to do that. We're going to take a sample and then we're going to estimate the true population proportion or mean. So we kind of have two vocabulary words of sorts. So a point estimator is a statistic. And remember, a statistic is a sample mean or a sample proportion. So it could either be an X bar or a P hat. And then the point estimate is the actual value of that statistic. So we would say, okay, what point estimator are we going to use? We're going to use X bar. And then here for point estimate, we would actually figure out what X bar is. So here's an example of that. So in each of the following settings, determine the point estimator you would use, and then calculate the value of the point estimate. So in part A, this is talking about lifetime of AA batteries. They select a random sample of 30 batteries during each hour of production and then drain them under conditions that mimic normal use. Here are the lifetimes and hours of the batteries from one such sample. So we have to figure out what point estimator we should use. So again, from the past page, a point estimator, basically you just choose whether you should be using an X bar or a P hat. So is this a proportion problem or is this a mean problem? Okay, and typically when you have numerical data, you might be interested in finding the average. So the point estimator in this problem is X bar. And then we would need to find the point estimate. So we would need to go to our calculator, type all the data in, give it a name at the top, and we're going to actually find the mean. So we do menu, statistics, stat calculations, one variable stats, one list. I called it battery. Hit OK. There's your X bar right there. So 16.7, and then I'm going to write it over here. And then what are the units on that? Well, we're talking about the lifetime of the battery in hours. And they might want you to write it like the point estimator more in words. So this is the sample mean battery lifetime. Okay, for part B, what proportion of U.S. high school students smoke? The 2007 Youth Risk Behavioral Survey questioned a random sample of 14,041 students, grades 9 through 12. Of these, 2,808 said they had smoked cigarettes at least one day in the past month. Point estimator. Well, is this a mean problem or a proportion problem? It says proportion right here. So our point estimator would be P hat. This is the proportion of those in the sample. that smoke. Okay, and then our point estimate would be actually figuring out that value. So what does p hat equal? So how many students out of how many students smoked? So it was 2808 out of our sample of 14. Oh, I'm running out of room. Here we go. 14,041. So you would type that in your calculator and you're going to get this. So 19.99% of people in the sample said that they smoked. So the whole point of a confidence interval is we're going to be taking what we got in our sample and we're going to try to estimate what the actual mean, mu, is. Or here we would take the p hat that we got in our sample and we're going to try to estimate what the actual population proportion p is. Okay, so here's more information about a confidence interval. This is the most basic way to think of it. So you have your point estimate, which again on the last page was either an x bar or a p hat. And I have that written right here. Your point estimate plus or minus a margin of error. So if this is what we got in our sample, we're going to add a margin of error and that'll give us an upper bound. We'll subtract a margin of error that'll give us a lower bound. And then we would be saying that we are pretty sure that the true mean or the true proportion lies somewhere between here and here. So this is like those strips we put on the back of the wall yesterday. We put the pin in the middle, and then we had a strip to the right, and then we had a strip to the left. So I would make sure that you have this written down, or if you printed off the blank notes that I posted, you could just be filling things in. So this will either be an x bar or a p hat, and then this will be some margin of error that we calculate. Now we can calculate it, and it's based on the confidence level times the standard deviation of the statistic. That's what this is abbreviated right here. Confidence level times standard deviation. Standard deviation formulas is what we learned last chapter. Confidence level, that's something new. And typically we use a 90, 95, or 99% confidence level. So this is like a success rate. And we want to be very successful in our predictions. So we like to have them up in the 90s. Now you're going to have to, in the homework, probably talk about margin of error or interpret it. And that's what this yellow stuff is. This is kind of how you would interpret margin of error. Okay, so what this says is the margin of error tells us how close our estimate, so that's an x bar or a p hat, how close our estimate is to the unknown parameter. The unknown parameter is either mu or p in repeated random sampling. So if we did this a lot, if I had a 5% margin of error, my estimate, like my x bar, let's say, would be within 5% of the true mean mu. Okay, so moving on, this is just kind of funny because when you're talking about confidence intervals, we want to be very confident that we're going to be right. But in order to do that, you kind of need to have a wide window. So if we're talking about a weather person and they say, oh, tomorrow there's going to be between 1 and 78 inches of snow, well, duh, you're going to be right, but that's not very credible when you have that huge wide range. So it'd be better if we could zoom in and say, oh, there's going to be between 6 to 8 inches of snow. This is the same kind of thing. High temperature will be between 40 below zero and 200 above. This guy is never wrong. Ha ha ha. Okay, so our goal, you would be a little bit more credible if you could zero in on the true parameter. Well, in order to zero in, you would need a smaller margin of error. Remember, this is your margin of error that you subtract from your point estimate, or this is the margin of error that you add on. So if you want to be more precise, you would need a smaller margin of error, but what that results in is less confidence. If you want more confidence, then you would make your margin of error bigger so that your range of your confidence interval is wider. Wider, just like these problems, 1 to 78. That's really wide, but they're going to have a very high confidence. So it's a trade-off. Okay, so this looks like what we did on the back of the board. So each of these little strips is a sample that was taken. Well, I should be more precise. Each of these red dots is a sample mean, or it could be a sample proportion depending on the problem. And then if you add a margin of error and subtract a margin of error, you get these strips called confidence intervals. Now, we're trying to estimate what the true population mean or proportion is. So this would correspond to this line down here. And so you can see that most of our samples hit that line. But this is a sample that was just fluky and it stood way out and it did not actually capture the true mean like we were hoping to. So maybe this one right here had some bad sampling technique or something. So you want to do the best you can in your sampling with the whole idea that you want to be able to like cast a net. Think of these lines as like a net, and you want to catch the true mean. Or if it was a proportion, you'd want to catch the true proportion. Okay, so you're going to have in the homework where you need to figure out the confidence level. So again, remember the confidence level is probably going to be like 90, 95, or 99, but it could really be any percentage. So the way that you figure it out is in the green box here. You count the number of confidence intervals that contain the true population mean or proportion, and then divide by the total number of intervals. So how many intervals are there here? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So there's 25 intervals. We need to figure out how many actually hit. It looks like all hit except this one. So that's 24 out of the 25 that actually hit the true mean. So if you divide that in your calculator, you're going to get 0.96. So this would be a 96% confidence level. And in the homework, you're going to be asked to interpret a confidence level, and that is in this blue box. Let me try to get this to scroll down a little bit. Oops. There we go. Okay, so this is interpreting the confidence level. So if we were to repeat our sampling many times, like not just take one sample, but take lots of samples, repeat the sampling many times, then about, in this case, about 96% of these confidence intervals would actually contain the true, whatever it is, mean or proportion. And then explain what the context of the problem is. So put everything in the context of the problem. So that's how you interpret confidence level. You're also going to be asked to interpret the confidence interval. And this is something that you're going to get really good at because you're going to do it so much. Um, Whatever your confidence level was, it's like in the last problem, I would say like I'm 96% confident that the interval from, and then you would figure out the numbers, and I'll show you that in a minute, but like let's say 0.70 to 0.74 captures the true mean, and then mean of what? Put it in the context of the problem. Okay. Any interpretations that are talking about probability are not correct. It's not a 96% chance or anything like that. It's just 96% of these strips hit the mean if you took a lot of samples. Okay, so we're going to just do an example and then you'll be done and you can work on the homework. So part A, explain what the margin of error means in this setting. Okay, so what was margin of error? This is a Gallup poll, 59% of people in the sample. Okay, so actually, first of all, let's figure what is that 59% if it came from a sample. So that's a proportion that came from a sample. So is that P or is that P hat? Well, if it came from a sample, that's P hat. So P hat is 0.59. So 59% said yes, that they would like to lose weight. They're using a 95% confidence level. So just kind of keep that in mind. The margin of error is plus or minus 3%. Okay, so what is this margin of error? What does it mean? So to refer back to this page, remember the margin of error tells us how close our estimate, in this case it's a p hat, is to the unknown parameter p if we did this sampling lots of times. So what I would say is if we were to repeat the sampling procedure many times, on average, the sample proportion, that's our p hat, would be within 3 percentage points of the true proportion. So our sample proportion, p hat, would be within 3 percentage points of the true proportion p. Okay, then for part B, we're supposed to state and interpret the 95% confidence interval. Oh, here it is, confidence interval. So this is the interpretation of that. So for part B, I'm going to actually write it out. Okay, so referring back to here, I am 95% confident that the interval from where to where, we have to figure that out. Okay, so we have to actually figure out what this interval is. So go back. Here's your formula for a confidence interval. Point estimate plus or minus margin of error. Point estimate plus or minus margin of error. All right, what was the point estimate again in this case? Remember, a point estimate was either x bar or p hat. So in this case, it's p hat. So our point estimate is 0.59. Plus or minus our margin of error was 3 percentage points, so 0.03. Okay, so if you subtract 0.03 from 0.59, you get 0.56. That would be the lower bound. And if you add 0.03 to 0.59, you get 0.62. That would be the upper bound. So that's our interval. So we're going to be 95% confident that the true population proportion is somewhere between 56 and 62%. Okay, so I'm going to continue my writing. I'm 95% confident that the interval from 0.56 to 0.62 um, captures the true proportion of people who would want to do what? Like to lose weight. Okay, so again, you're taking this little sample, and in our sample, it was 59%. We're going to use that to estimate what the whole population thinks. We've got this margin of error that we added and subtracted. So we're pretty sure that the population is the proportion of people in the population who want to lose weight is somewhere between 56% and 62%. And that's kind of a wide range, but again, we have high confidence. So the higher the confidence, the wider the interval. Okay, part C. Maybe I'll do this in a different color. Interpret the confidence level. Confidence level interpretation is down here, remember? So if we were to repeat the sampling procedure many times, about, in our case, it was 95% of the confidence intervals would contain the true, and in this problem it was proportion of, and then we're supposed to put in the context of the problem. So proportion of people who want to lose weight. So if we were to take many samples, about 95%, because that's our confidence level, about 95% of the confidence intervals would capture the true proportion in this problem of those who want to lose weight. So if you're interpreting the level, you're just talking basically about how many strips, what percent of the strips would hit the true proportion. So in this case, 95% of the strips would hit it. Interpreting the confidence interval is where you're saying, I'm pretty sure that the true interval is somewhere between here and here. So you have to figure out those numbers. And again, this is the main formula up here.